I'm focusing on how to build a hard voting ensemble using Sklearn's VotingClassifier. I'll be using 3 different machine learning models: logistic regression, LR, support vector machine, SVM, and random forest, RF. The challenge is to combine these 3 models into a single, more powerful model using a technique called hard voting. I'll show you how to do this correctly using Sklearn. Here are different code examples. I will help you figure out which ones correctly create this hard voting ensemble. This code snippet explicitly creates a voting classifier with hard voting. The estimator's parameter is a list of tuples where each tuple contains a model name and the model itself. The voting parameter is set to hard. This is a correct solution. This is incorrect. It uses soft voting, whereas the problem specifically asks for hard voting. In soft voting, the final prediction is decided by averaging the probability scores from each base model. In hard voting, it's simply majority rules based on the model's predicted class label. This is a perfectly valid alternative way of constructing a hard voting ensemble. The estimator's list is defined separately, which is fine. The code still explicitly uses hard voting, so it's correct. This works because even if you don't specify the voting parameter, Sklearn's VotingClassifier defaults to hard voting. It's a correct but slightly less explicit approach. This is the question prompt. Determine which code snippets correctly implement a hard voting classifier. I see this as the central question of the quiz. We need to identify which code examples correctly build a VotingClassifier that uses hard voting, a method where the final class prediction is the one receiving the majority of votes from the individual classifiers. This code snippet creates a VotingClassifier. I like this one. It explicitly sets the voting parameter to hard, which is exactly what we want. The estimators parameter is a list of tuples. Each tuple contains a name, a string, and its corresponding classifier object. For example, LR means logistic regression, is the name assigned to the logistic regression classifier object LR. Here's another correct approach. This code example uses a variable, estimators, to store the list of classifier tuples, making the code more organized. Neat, right? Again, it clearly sets voting to hard. The third example is similar to the first one. It creates a VotingClassifier with the same estimators. The clever bit is that it omits the voting parameter. In Sklearn's VotingClassifier, hard voting is the default, so we get hard voting without explicitly stating it. This works perfectly. This title introduces the topic. We're learning about a Sklearn tool called VotingClassifier, specifically how to use it for hardvoting. Think of it like a group decision-making process where the majority rules. I'm going to give you a coding challenge. We'll build a VotingClassifier using 3 different machine learning models: logistic regression, support vector machine, and random forest. The goal is to make sure you understand how to create a hard voting ensemble, meaning the final prediction is decided by the majority vote of those 3 models. The correct answers to the challenge are A, C, and D. I will explain why later on in the explanation section. Options A, C, and D all successfully create a VotingClassifier that performs hard voting. The key is understanding that the default behavior of VotingClassifier is already set to hard voting. This means you don't need to always explicitly state it. The VotingClassifier cleverly defaults to hard voting, which means you can make a hard voting classifier without explicitly setting the voting parameter. That's why option D works. Even though voting equals hard isn't stated directly. I see this line creates a VotingClassifier. I'm using three models: logistic regression, LR, support vector machine, SVM, and random forest, RF. The ESTIMATORS parameter is a list of tuples, each containing a model name and the model itself. The part means the final classification decision will be based on the majority vote. Whichever class gets the most votes from the individual models wins. Pretty straightforward, right? This line is very similar to the previous one. The only difference is, this time, instead of a majority vote, I'll be averaging the predicted probabilities from each model. Each model gives a probability for each class. I average those probabilities, and the class with the highest average probability wins. It's a softer, more probabilistic approach compared to the hard voting in the previous example. Here's another way to make a VotingClassifier. I am using the same three models, but I haven't explicitly specified the voting type. That's okay because, by default, VotingClassifier uses hard voting. So, even without, it will still work exactly like the first option, majority rules. This is a neat shortcut that shows the default behavior. This is just a comment adding that the default voting method is hard. The actual code is the same as the previous example, performing hard voting. The comment simply clarifies what the code implicitly does. This refers to a logistic regression model, abbreviated as LR. It's one of the base classifiers used in the voting ensemble. This refers to a support vector machine model, abbreviated as SVM, another base classifier for my ensemble. This refers to a random forest model, abbreviated as RF, the final base classifier for the ensemble. This is the core ensemble method. I'm using a VotingClassifier to combine the predictions of the three models. It's like a team of experts where the final decision is made democratically or probabilistically, depending on the voting method. This indicates the output of the VotingClassifier, the final class prediction made after combining the predictions of the individual models. That is the result of our ensemble's combined wisdom. I'm explaining the concept of hard voting within Sklearn's voting classifier. It's a way to combine multiple machine learning models to make a more accurate prediction. Think of it like this: you have three friends who each predict the weather. I'll consider them to be my logistic regression, SVM, and random forest models. In hard voting, each friend makes a prediction. The weather prediction that most friends agree on wins. That's the hard part. We're not considering confidence levels or probabilities, just the final answer. It's a simple majority vote. That's an abbreviation for support vector machine, a powerful classification model. It aims to find the best hyperplane to separate different data points. Imagine drawing a line that perfectly separates apples from oranges. That's essentially what an SVM does, but in higher dimensions. A random forest is an ensemble method, similar to a voting classifier but operates differently. It combines multiple decision trees, each trained on a different random subset of the data. The final prediction is made by aggregating the results of all these individual decision trees. Think of it like a council of wise decision-making trees voting on the best outcome. This refers to using the voting classifier specifically for hard voting. It's a method for combining predictions from several different models. Each model votes for a class, and the class with the most votes wins. It's like a simple, democratic election among my logistic regression, SVM, and random forest models. I'm asking you to create a model that uses hard voting to combine the predictions of a logistic regression model, an SVM model, and a random forest model using Sklearn's built-in voting classifier. It's a practical exercise in combining different machine learning techniques. This line of code creates a hard voting ensemble. Let's break it down. Voting classifier is the function. Estimators is the list specifying the individual models. LR SVM RF and voting equals hard specifies the voting type. The parentheses indicate that we're calling the function, not just declaring it. The code explicitly sets the voting method to hard voting. This is incorrect because it uses soft voting rather than hard voting as requested. In soft voting, the probabilities of each class from each model are averaged, and the class with the highest average probability wins. It's a more nuanced approach than the simple majority vote in hard voting. This is a correct way to create a hard voting ensemble. Even though voting isn't explicitly defined, the voting classifier in scikit-learn defaults to hard voting if voting isn't specified, making this a perfectly valid solution. This question asks you to build a hard voting ensemble using 3 different machine learning models: logistic regression, support vector machine, and random forest. I'll guide you through how to do this using scikit-learn's voting classifier. The key is understanding how to set up the estimators and choose the right voting method. This code snippet is correct because it explicitly uses the voting equals hard argument within the voting classifier. This ensures that the ensemble uses hard voting, meaning the final prediction is the class that receives the most votes from the individual models. Similar to option A, this also correctly creates a hard voting ensemble. Although the method of specifying the estimators is slightly different, the outcome is the same. The voting equals hard argument is explicitly set, resulting in a hard voting ensemble. This is correct because the voting classifier defaults to voting equals hard if you don't specify otherwise. Even without explicitly mentioning voting equals hard the code creates a hard voting ensemble. Scikit-learn's thoughtful default makes this a valid solution. This is the scikit-learn class used to create an ensemble of classifiers. Voting classifier combines predictions from multiple models to improve overall performance. Understanding its parameters, estimators and voting is key to this question. This is one of the 3 individual models used in the ensemble. Logistic regression is a linear model used for classification problems. It's a common and effective choice for many tasks. Support vector machine, SVM, is another model used here. SVMs are known for their ability to handle high-dimensional data and are powerful classifiers. Their inclusion enhances the ensemble's diversity. Random forest is the third model. It's an ensemble method itself, combining multiple decision trees. The use of a random forest adds robustness and reduces the risk of overfitting. The ultimate goal of the ensemble is to improve prediction accuracy. By combining the strengths of different models, the voting classifier aims to make more accurate classifications than any single model could achieve on its own. This is the title of the problem. I'm building a classification model, a type of machine learning model that predicts which category something belongs to, using a technique called hard voting ensemble, with a library called scikit-learn. It's a fancy way of saying I'm combining multiple simpler models to make a more accurate prediction. This introduces the question, which tests your understanding of how to combine 3 different classification models into a single, more powerful ensemble model using scikit-learn's VotingClassifier. This sets the stage. We're using 3 pre-trained models: logistic regression, LR, support vector machine, SVM, and random forest, RF. I want to combine them using hard voting. This is option A, one of the possible solutions to the problem. I will check if this code correctly creates a VotingClassifier with hard voting. This shows the code for option A. I'll analyze this code to determine if it correctly uses the VotingClassifier with hard voting. This is option B, another possible solution. I'll examine this option to see if it's a valid way to create the ensemble classifier using hard voting. This shows the code for option B. I'll check if this code correctly sets up the VotingClassifier. This is option C. I'll analyze the code in this option to determine if it's a correct implementation of a hard voting ensemble model. This shows the code for option C. I'll review this code for correct usage of the VotingClassifier. This is option D, the last possibility. Let's see if it meets the requirements of the question. Does it use hard voting correctly? This shows the code for option D. I will examine this code to determine if it correctly creates a VotingClassifier for a hard voting ensemble. This line, and the similar lines in 14 and 16, shows the beginning of the code for building a voting classifier. The F at the end is a typo, it should be backquote. This line also shows the start of a code snippet, with the same typo as line 13. This should be corrected. This is a part of code snippet B. This line shows the beginning of a code snippet. The I is a typo, it should read backquote. This is a part of code snippet C. Similar to lines 13 and 14, this is the beginning of a code snippet, but with a typo at the end. This should read backquote. This is a part of code snippet D.